developers currently interacting with AI coding assistants rely on generic text editors or ad hoc chat windows to assign and manage tasks. This workflow creates an exhausting loop, copying a block of code, pasting it into a chat, and writing paragraphs of instructions that must be manually tweaked when the AI misses the mark. Managing these one-off prompt snippets adds a layer of manual overhead to every recurring software task, slowing down the development cycle. The technical flaw is that unstructured text fails to provide strict programmatic constraints for the AI model to follow. Engineering requires repeatable, deterministic results. If a developer runs a build process 10 times, they expect the exact same output 10 times. Relying on loose conversational prompts leads to unpredictable code outputs, particularly during complex or recurring operations. Personal prompt libraries eventually become technical liabilities that mask the true potential of an AI agent. To understand why conversational prompts fail, we have to look at the internal processing mechanics of an AI model executing a multi-step coding sequence. The primary enemy of complex agentic workflows is a phenomenon called context collapse. As a developer and an AI model exchange multiple messages, the model progressively loses track of the original rules and instructions. This diagram illustrates how a simple text prompt degrades. A clear instruction enters the session, but fractures into unlinked variables over an extended conversation timeline. By the fifth or sixth turn, this degradation results directly in off-task behavior and non-deterministic hallucinations. For the developer, this results in hours spent manually debugging logic and babysitting an agent that has lost its original operating parameters. Hallucination in routine tasks is rarely a failure of the AI model itself. Rather, it is a failure to enforce strict operating boundaries. Developers requiring reliable outputs must move away from loose chat messages and toward structured operating instructions. The SKILL.md playbook serves as a version-controlled document that locks the AI into a rigid set of rules, behaviors, and expected outputs. This schematic shows how separating the document into blocks for context, rules, and output format forces the LLM to verify constraints before it writes a single line of code. This structure prevents context collapse by continually reinforcing the boundaries of the task at every step of the operation. By imposing these constraints, unpredictable AI chat is transformed into stable software capabilities. Structured playbooks replace manual supervision with automated technical discipline. The barrier to adopting these playbooks is the fragmented architecture of modern development environments. Tools like Cursor, Claude Code, and Gemini CLI require different configuration paths to recognize and execute local skills. The open-source repository Antigravity Awesome Skills functions as a standardized library to bridge this gap between tools. The scale of the Antigravity repository introduces a catalog of pre-configured behaviors designed to lock into these shifting environments. It contains over 1,445 purpose-built skills, covering development, testing, security, and infrastructure. Manually downloading and routing 1,400 individual files into specific IDE folders is a task no developer has time to perform. To solve this, the repository uses a Universal Installer CLI, triggered by the command npx Antigravity Awesome Skills. This diagram shows the CLI's routing function, automatically sending playbooks into the required host directory based on the chosen tool. As data travels, the installer translates syntax on the fly, ensuring Claude Code and Cursor receive instructions in their exact required format. A single terminal command standardizes the ANDI workspace without requiring manual file configuration. The Universal Installer removes platform friction, turning a theoretical catalog into an instantly deployable local asset. Utilizing a library of this size introduces a technical challenge: choice overload. Forcing an AI agent to index all 1,400 skills simultaneously will bloat the context window and eventually crash the system. To manage this, the repository uses role-based bundles to curate the active skills. Bundles for SaaS development or security auditing load only the exact instructions required for that specific objective. For new projects, developers rely on Universal Starter Skills, foundation playbooks that establish technical discipline. These two commands, @brainstorming and @test-driven development, are the most critical starting points. The brainstorming skill enforces strict technical planning and logic verification before the agent begins any implementation. The test-driven development skill locks the agent into a rigorous loop, requiring tests to pass before it is permitted to write new features. Using bundles and starter skills transforms a massive database into a set of precise tools that protect the model's context limits. This architecture creates a standardized workspace where developers operate within a fully equipped agentic environment rather than an empty terminal. The anti-gravity architecture establishes functional parity across different platforms. As this diagram shows, identical logic commands can be executed regardless of the chosen AI coding assistant. This parity allows developers to focus on software architecture and design rather than memorizing tool-specific syntax. Embracing an installed library of structured skills limits hallucination and reduces the time spent correcting basic AI errors. Are you still writing manual prompts, or have you switched to structured skills? Let us know your favorite AI workflow in the comments below.